Okay, welcome back for the last session before lunch. And you guys who have been here with us for also yesterday, you have seen also technical proposals and solutions. But in the challenge lab, we work on all levels, landscape, regime, and niche levels. You want to be looking at that academic side. And now we're going to look at with this master thesis on more of a landscape level. What are the policy changes that are needed for something new to arise? And this is specifically a transformation towards a fossil-free region with the help of the ocean, and more specifically algae and utilization of that. So welcome up, Taina, for your presentation.
Thank you, David. Yes, I'll jump right in. It changes the slide on my computer, but not on the screen.
Try again.
Welcome to the future.
I
usually say that Moore's law and Murphy's law are sort of always there with us when it comes to technology.
Like this, slide one.
Yeah. Let's see. Let's do it like this.
No, wait.
The fail-safe thing is always to unplug, unplug.
So it depends on how it's set.
Let's see.
Okay. Yes, perfect. Yeah, my presentation today is structured in a way that I will first present my research objective, present to you the analytical framework that I used, go through the steps I took to reach my results, and then present my empirical findings, and end with my conclusion. The research objective I identified by applying the backcasting process together with the other Challenge Lab students. And when we set down our criteria for sustainability, we had one of the criteria as being resources are used indefinitely non-depleting, which kind of aims at a rather circular products and services. My thesis was then also guided by the climate goal of the region Västra Götaland, which aims at becoming fossil independent by the year 2030. When we looked at the present system, I found the same problem as Simon and Lovisa, that value chains are rather linear, and in my case, they're also often based on fossil resources. At the stakeholder seminar, I was then presented with algae posing opportunities as a bio-based circular product. And my thesis then tackles the fourth step to develop a strategy towards sustainability. And the two research questions I posed was, does macroalgae currently contribute to the transition towards a sustainable future in Western Sweden? And then it went on by asking, how does the prospective potential look like? Yeah. The analytical framework I used is called Technological Innovation Systems, shortly it's called TIS. So what is a TIS? It's what is embedded in the interaction of actors, institutions, and infrastructure. And this is a framework that was originally constructed to study innovation processes. It's it has 4 steps, that with the first one being defining my TIS and focus, followed by a structural analysis, by a functional analysis, and then my result are policy recommendations. If you look at this, it looks like a rather linear approach, but it had a lot of iterations on the steps which were carried out more in a circular than a linear manner. Now I'm just going to explain to you the 4 steps in a more detailed manner. The TIS and focus is set by looking at 3 different aspects, with the first one being the focus of attention. The question is, do I want to look at a product or rather a technological field? With the second aspect being the level of detail and the range of applications, where the question is, do I rather want an overview of the broad picture or an insight into specific aspects? And lastly, the spatial domain, where the geographical scope is defined, where you can either look at a regional scope, a national or international scope. In my thesis, I express these 3 aspects by creating a value chain that I then further evaluated. The first analysis is the structural analysis, which answers the question, which structural components are involved. The first group of components are actors. They come from various backgrounds, and then they can be categorized in very different ways. But I mainly look at the civil society, companies, knowledge institutions, and the government. Institutions are made up of rules and laws which shape then the common habits that we live under, and the common habits then again change the rules and laws that are made up, and they're classified as hard and soft institutions. Interactions is pretty self-explanatory. They're either carried out as individual contacts or as networks. And the last component sums up the aspects which were not included in the first 3 ones, and it just simply uses the classification as physical infrastructure, knowledge, and financial infrastructure. The structural analysis then is the foundation for the functional analysis, which aims to answer the question, how is this system that is made up of the components, how is it functioning? And therefore, we use a categorization into 7 functions. And I'm shortly going to explain all of them. The entrepreneurial activities, they express the number of new entrants into the TIS and the number of new applications that are tried out within the TIS. Knowledge development is the core process of innovation processes, and this function tries to capture the breadth and the depth of my knowledge base. And then besides knowledge development, it also has to be diffused within the networks. And this is, for example, measured by conferences or workshops that are carried out. Guidance of search tries to capture the mechanisms that influence the direction that a technology is being developed within. It's difficult to measure in a quantifiable way because it rather expresses expectations and perceptions. Market formation tries to capture how well market niches are developed for technologies to develop within, and is a necessary input for development processes. Then, of course, resources are necessary to carry out all kinds of developments. and they're classified as human, financial, and physical resources. Then the final function is the creation of legitimacy. This is a process necessary to reach social acceptance and to reach conformity within relevant institutions. And this function captures the lobbying strength of actors. After conducting this analysis, the result that I get from it are what is driving my development and what is hindering it. The last step then to develop policy recommendations is aiming at the question which actions are necessary for the technology to reach its full potential. So this was the background that you need to understand my thesis. And the starting point for my thesis was the interest from the Western Swedish Chemical and Material Cluster, who in collaboration with the Maritime Cluster are exploring the opportunities of marine and aquatic raw materials, which they organized a seminar for in March. To prepare for this seminar that I also attended, I collected data on what is TIS and a bit on macroalgae, and I presented the research project during the seminar where I got in contact with interested stakeholders and got a first overview of the situation. I then went on and conducted 10 interviews with those interested stakeholders and analyzed the data I collected according to the TIS framework, with the outcome being my barriers and drivers and the policy recommendations. Before going into the analysis, I'm going to supply you with the relevant knowledge you need to have on macroalgae. And algae in general are what we call photosynthetic organisms, which means that they produce biomass from sunlight, carbon dioxide, and nutrients such as nitrogen and phosphorus. Within their natural environment, you can, for example, find algae on the Swedish west coast. They provide food and shelter to other marine organisms. And what's relevant to this thesis is that they provide ecosystem services, which are services provided by nature that are beneficial to human activity, with one of them being that they convert the greenhouse gas carbon dioxide into oxygen. And the second, which was most relevant to this thesis, is that they have the ability to mitigate eutrophication, which means that they take out excess nutrients that were caused by human activities in the water and implement them into biomass. When I think of algae, I think of sushi, and that's right, algae has a long tradition being utilized commercially in Asia rather than in Europe. And when we talk about algae, it's classified according to its size into microalgae and macroalgae. And in my thesis, I went with macroalgae as a species, which is then again classified according to its color in brown, green, and red macroalgae. And out of simplicity reasons, I decided to only look at brown macroalgae. So every time I talk about macroalgae here, I mean brown macroalgae. Good. Going over to my analysis. The TIS and focus, as I said, I define by developing the value chain, which I'm now going to explain to you. And it starts with the cultivation of macroalgae, which is first carried out in the lab, where little spores are grown, which are then put on ropes, which are placed in the sea. when harvesting the macroalgae, it has to be stored and preserved to prevent imminent decomposition. The first product that can be used is to utilize the algae as a raw material, for example, as food. And the industrial way of processing it, which was traditionally used, thought of, is to produce biogas. However, this is rather economically unfeasible because it has to compete with household waste and other kind of biomass. Therefore, a group of researchers thought that it would be good to put an intermediate step, which is the biorefinery. You can imagine this by playing with Legos, where you have a big chunk of Lego, which you disassemble into smaller parts and then put together into several different products, such as materials, energy, animal feed, or processed food. The residues from the biorefinery could then be used to produce biogas, and the residues from the biogas production could be used to produce fertilizer, which then could close the circular value chain by being utilized to cultivate new macroalgae. I also found in my thesis that the value chain of macroalgae is interacting with other value chains, especially when it comes to the cultivation, where it could be symbiotic effects with the cultivation of mussels or the cultivation of sea squirt. However, this was quite too big value chain to look at, which is why I decided to just focus on these steps. From here on, I went and analyzed the structural components that were connected to the different steps of the value chain, with the first one being the actors. And I found that they were making up the majority of components. I first then looked at the step of cultivation, where I found various actors, with the first ones coming from the government, such as the municipality, the county administrative board, and the land and environment court. This step is also heavily researched at Gothenburg University. And the third group of actors I found was a startup which is currently planning to commercially cultivate macroalgae, which he did in collaboration with a small food producer. The storage and preservation step is mainly researched at the moment, which leads me to my first product. There are a couple of small enterprises in the Gothenburg area who sell food, but they skipped the step of cultivating macroalgae themselves. They rather went out and harvested wild macroalgae. But what they do is, for example, they implement algae into bread, or they provide a culinary experience around harvesting macroalgae and to eating them in gourmet restaurants. The steps of biogas and biorefinery, the actors I identified there, were companies that transferred the knowledge that they gained on their primary operations to support the development of technologies that were suitable for algae, and again, a lot of research activities. The product group that could come out of the biorefinery, the materials, there is always an interest from the industry to purchase materials on competitive market prices. I then went on to the second components. the hard institutions, where I found regulations and issues concerning the regulations, especially for the cultivation. This arises from the fact that the Swedish Environmental Code, which sums up all regulations on the environment, it was created 20 years ago at a time where, when they made the cultivation regulations, they only included, for example, fish and mussels, but no one at that time thought of cultivating macroalgae. Therefore, another chapter applies, and this chapter makes it a bit harder to attain a permit, because it says that this permit needs to be issued by the county administrative board. There's then an ordinance which clarifies the permit process, and it says that if you want to carry out any water operations which macroalgae falls under, you need to go to the environmental court and get a permit there if you want to cultivate an area bigger than 3,000 square meters. Compared to getting a permit for fish and mussels, this is time intensive, this is really money intensive, and it has an environmental assessment that is of large intensity. I then looked at the soft institutions, and I found that there were a lot of different expectations concerning the future of macroalgae, whereas on one hand, there was enthusiasm coming from actors that were not directly involved in developing the value chain, but rather had an interest in the positive impact on the climate that developing the system would have. On the other hand, there were entrepreneurs directly involved in the cultivation, mainly of mussels, and they voiced that their optimism was dampened due to the regulatory obstacles. And And lastly, there's a strong financial support currently for developing these fossil independent solutions, which is why I identified a strong belief in the growth of this technology. The third component, the interactions, were mainly carried out in research networks that were either aimed at macroalgae or more towards the collaborative research on marine sciences. And they were either on an international level for conferences, for example, or on a national level in Sweden for research projects. And one research project I would like to point out here is the Sea Farm project. It's a Swedish initiative of an interdisciplinary research project that was founded 4 years ago. And they developed this value chain that I'm using today, and they're aiming at closing the loop of the value chain and developing a system with zero waste. Additionally, the clusters John talked about earlier also apply to this value chain in the case of the maritime cluster for the cultivation and support from the chemical and material cluster for developing materials that come from the biorefinery. And lastly, the infrastructure. As I said, those connecting value chains for the cultivation of mussels and seaweed, they show that there's the possibility of using shared infrastructure such as boats and warehouses. And this physical infrastructure caused an interdisciplinary knowledge base to form, which is also supported by research activities. For example, there is a research station in Tjärnö, which covers all marine sciences. And then, again, as you can see, this is a heavily research-based activity here. So, of course, it relies on funding, which is provided by various sources such as the research foundations, but also the regions and the municipalities. And now comes the heavy part of my analysis, the functional analysis, which I carried out by first looking at the 7 functions individually. I then collected strengths and weaknesses of each functions and clustered them together, the strength into drivers and the weaknesses into barriers, which I'm now going to present. For example, this first driver, I found strength in 3 of the functions, and they could be clustered together into the driver that is the cooperation between researchers themselves, but also between researchers and entrepreneurs. And this driver is then again connected to the CFORM project, where researchers together with local entrepreneurs are trying to develop this feasible value chain, and they, for example, the cultivation of macroalgae within the research was made possible because the local food producer was holding a permit for land to cultivate on, where he did not have the knowledge to do the cultivation, so he benefited in terms of developed knowledge and cultivated algae. Additionally, to obtain funding for this project, researchers from all over Sweden gathered together and created this vision of creating this value chain, which resulted in a strong guidance of the search. And one outcome of this project was that the strength of the researcher network was increased because it connected their individual research into a bigger collaboration and resulted of diffusion of knowledge within the research community, but also within the researchers and entrepreneurs. The second driver, entrepreneurial spirit, I named that one because for me it seemed like it was an exceptional attribute of this TIS. Over the last years, entrepreneurs working with macroalgae as food found a market niche to operate within without having knowledge to rely on, which is why they developed expertise through learning by doing. And originally, this market niche was only for food, but now the new one is emerging, connected to the cultivation of macroalgae. The third driver that I identified is the favorable funding situation for fossil independent solution, which enabled the mobilization of resources to facilitate the process of knowledge development on this technology. As this interest in funding those research projects is known to the research community, it is one factor that might cause them to align their research to what's asked for by research foundations, which is then an influencer of the guidance of the search. The last driver I identified is the shared infrastructure and interactions with other sectors. And this is especially for the cultivation enabling the development of the focal TIS. Additionally, to simply cultivating algae, there's also the possibility of co-cultivation and biological symbiosis when cultivating algae together with mussels. And therefore, there's collaborative research done on this topic, which means that knowledge developed, for example, for this co-cultivation is also possibly to spill over and to diffuse to develop the simple technology of cultivating algae. And additionally, the shared physical resources between interacting value chains, for example, the machines from mussel farming that could be used for algae, or processing equipment used for other types of biomass to produce biogas, is what is facilitating the development of this value chain. Now from the drivers to the barriers. The first barrier that I identified was the lack of variety in entrepreneurial activities, which arises because the only current noteworthy activities are carried out in the market niche of food. However, this market only has a limited capacity, which is why there's the need to diversify the product range made out of algae. And another reason is that there's so heavy research activities on this topic that the knowledge is just developed at the moment, which complicates the emergence of new enterprises. The second barrier that I identified is the lack of obvious market. And this lack affects not only algae, but all marine species. At the workshop, there was a statement done that said sea farmers need agricultural conditions. And I think that this highlights the legal disadvantage sea farmers are under compared to agricultural farmers, and that it unites the actors in lobbying together for legislative changes. And the third barrier, the lack of actors with relevant knowledge, again, it connects to the fact that this TIS is only in an early developmental stage, and that thus it affects all the functions. The last barrier that I identified is the current legislation. It is the biggest barrier for further development because these legislative issues are hindering entrepreneurial activities, and thus they're obstructing market formation. I then continued to look at the barriers and think about how they could be overcome. And the first recommendation that I have is to simplify the cultivation permit application process, because this would not only affect developing the first step of the value chains, but also support the development of the further steps. In addition, the lack of subsidies for ecosystem services could be solved by providing subsidies for example, removing nutrients from the sea. And besides the legislative recommendations, it is also necessary to support the further development of the TIS. For example, the funding needs to be continued in order to further develop the knowledge. And lastly, it is necessary to generate incentives for new components to enter the market, because it would induce entrepreneurial activities, it would incentivize the growth of the knowledge base, and it would foster market formation. Now to sum up and to come back to my first research question, which was, does macroalgae currently contribute to a transition towards a sustainable future in Western Sweden? My answer is that it's a negligible contribution of macroalgae when you look at quantifiable manners. This arises because the required knowledge to do so is only currently developed, but small enterprises raise awareness on the opportunities that are out there, and the emerging enterprises give a positive outlook on the future. Which leads me to my second research question. Well, how does the future potential look like? And I think there is a big potential, but it depends on how well those recommendations are implemented, which would mean to address the blocking mechanisms, but also to induce the existing drivers. And these are crucial for the future success of macroalgae as a renewable resource in Western Sweden. Thanks.
Thank you, Zaina. And now it's time for opposition. So please, come up so you can.
Okay. Hi. So first, thank you for this presentation. It was really clear, and at least for me, it made it clearer than when I read your report, because the TNS is quite a complicated system. So kudos for doing this this analysis. It seems very good. And we thought that you had an overall good structure of the report, so it was easy to follow anyway. So that was good. However, we missed a little bit of connection to other algae research and how the implications to the field were. Can you comment on that, maybe?
The problem is that for technologies that are only being developed at the moment, they look at specific issues. And so far, no one had taken the approach at looking at the whole system of it, which is now taken on by the CFORM project, but it's rather connecting the different researchers and only slightly looking at what is necessary on a systems perspective. So I simply did not find a lot of information that I could rely on.
But you say in your report that algae are very much used in Asia, so couldn't you find anything in Asia where it is common business?
I think it's different if expertise is developed gradually over the years, and I think ocean conditions, I'm not an expert on this, but I think ocean conditions in Asia are quite different from ocean conditions on the Swedish west coast. And currently, I'm not sure how well knowledge spillovers from continents are working, because if you look at algae, they have the Swedish initiative, they have activities in Scandinavia, but I think then it already kind of fades out in a way where they might include Northern Europe.
Well, I think that's a good point, that the conditions maybe in the ocean are different. So then you mentioned that the environmental analyses are quite work intensive, but then I guess they're useful. They have to do it. So your stakeholders you interview, that they're aware of that.
But for example, if you cultivate algae, it now requires a more extensive environmental analysis than if you wanted to cultivate mussels. And I think that's why they disagree, that it would be understandable if the level of intensity would be comparable, but it does not make sense that one has to be more extensive than the other, whereas they don't have any toxic effects on the environment.
But that's like, I guess that's not entirely clear to me that it should be the same for the mussels and for the algae, because the algae, I don't know, it's not really, how are they similar in that sense?
The way, algae, they take up the nutrients from the sea, such as nitrogen and phosphorus, and they implement them in the biomass. So they pure the water, whereas mussels, they filter the water. So they don't filter out nutrients, they filter out small organisms, I'm not sure. So they do different things, but the effect on the environment is both positive and yes.
Yeah, makes sense.
Okay, maybe next, so the thesis is so central in your study. We thought maybe it should be in the title.
Yeah.
So that's just a comment maybe for the end report.
And did you think that the thesis was a good tool to use for this analysis, or to analyze the system?
I mean, I'm an engineer, so I liked to have a structured approach to qualitative research. And it was really helpful to me as I was guided by my supervisor into how to evaluate the system and which questions to ask. Because I think that's what it provides. It provides a lot of questions that you then can go on and answer.
You mentioned those ecosystem services and the subsidizing those ecosystem services, that they're all the same subsidizing as common agriculture, but because the ecosystem services they provide are probably different, so they provide the value maybe is different. Do they have some kind of research to support the claim for subsidizing the ecosystem services?
I mean, you can directly measure the amount of nitrogen and phosphorus they take up. But if you look at agricultural farming, they remove the nutrients on the site where the fertilizer puts in nutrients, and then they're subsidized, which I understood, to grow certain kinds of plants that take in excess nutrients. So if these excess nutrients are not taken out, it's carried on in the ocean. So it's not directly comparable because algae are not taking out nutrients at the source, and you can't say the nutrients we're taking out here, they're coming from here. It's more like, I don't know how to clarify this.
But then you also said that you could add the nutrients from the value chain to be able to grow the algae. So does it need to add? Do you need to add nutrients, or can you just grow them in the ocean as it is? This is not entirely clear to me how it's like the circularity works.
Let's think about our perfect future out there where there are no excess nutrients in the water. They're just nutrients that are supposed to be there, and not like today where there's an excess. So of course, if you don't have an excess of nutrients that is supposed to be taken out, you then have to put them back in. But currently there's no need to fertilize the algae in the sea, but of course when you grow them in the lab, they need nutrients that you need to provide.
And you talk about them being a contributor to the fossil-free region in 2030. Do you think that's feasible, that they could grow into that by that time, like the algae system? I know this is speculation, but
I mean, they could definitely go from no contribution to a certain contribution, which is a development that's also done despite the legal disadvantage. But then I don't want to speculate on how much. And
no. But what fossil resources? Because you say, like from the biorefinery, what fossil resources can you then replace that you see as significant?
For example, plastics are currently produced from oil, so there's the possibility of producing bioplastics. Then if the biogas production would actually become economically feasible, you could substitute other fossil energy sources.
That's good. I think I missed one question from the methods thing, because it wasn't really clear how you did in between of the data collection and the TIS. Like you said, you did the semi-structured interviews. But then, how did you document them, and how did you analyze the data from the, like, how did you categorize the data before going into the test?
Well, the first part, our interviews, we did not record. We rather went and took notes of what's important, and then if there were questions left, we went back to the interviewees. And the approach to process the data was so straightforward with the analytical framework that I did it more without thinking. But then when it came to barriers and drivers, I think I explained my method a little bit there.
Do you feel like that made you, like, because sometimes when you take notes, there's a risk of bias, for example. Do you feel like you were able to avoid that?
I did not see a problem there.
No.
Especially since it's always two people.
Yeah.
That I did not conduct the interviews myself, like alone. So I think if two people look at what's written down and discuss that after an interview, there's not so much misinformation.
Yeah, makes sense. So the final question that I had was that these recommendations, who do you think should take them and go forward and do something?
I heard that there's an interest in looking more at the system's perspective and asking why does nothing happen. So there's one person interested in my research, and then again, the actors that are already lobbying.
So there will be more of a lobbying perspective, because I see, like, legislation, then you have to go to a national level. Or
I met with a law student who explained me the situation and what could be done. I did not completely understand it in a way that I would present it in front of everyone. The possibilities where you could also go into lower levels and do smaller changes instead of changing the whole Swedish environmental code.
Yeah, so this is something you would bring to, like, the region or the municipality or something?
Yes, but that's more qualified people that are currently looking into that.
No further questions. Thank you.
Thank you for the questions. Now it's time for your questions. So I guess you have many questions you want to fire away. Boo, you have been working in the ocean, I almost said, but with this question for many, many years.
Yeah. Very interesting. One thing, of course, is any kind of aquaculture is a conflict with boating. And have you looked into the possibility to co-locate, for instance, with areas that will anyway be closed off, like the marine wind energy areas? Because there will be they will close off for boating, and there will also be infrastructure that could be a convenient place for these kind of ventures.
That was so far out of the scope of my thesis, but it would be really interesting to look at the possibilities that poses. But I haven't found anyone who's currently doing that.
And the second question, I mean, you said that the present this kind of agriculture has rather minor impact. What's the real potential for scalability, from your perspective? What would be most essential for scaling?
Are you only talking about the cultivation or the whole value chain?
The whole value chain.
Yeah. Well, the necessity for scale up of the whole value chain is that there's enough cultivated algae, because otherwise the rest can't follow. And from what I understood, the development of scaling up technology for cultivation is actually quite feasible. It is more the limit of cultivation area currently that could stand in the way, rather than the technology not being developed. And then the problem is that because the products that are produced have to compete with the products that are already on the market, they have to some extent be able to compete with those solutions. So this development to make it economically feasible is necessary for the scale up. But then I think there's a big potential.
Yeah, maybe more, I don't know, a comment, or because I also went to the workshop where you were. And I mean, it's very interesting because people are talking that we have to subsidize products that are doing ecosystem services. But wouldn't it be better, or is anyone talking about instead like taxing the bad guys? I mean, instead of just hiring the good guys, can't you just, carrot and stick? I mean, maybe you should just, I mean, it's also you should treat them differently. I mean, they are already subsidized, so is that also a possibility? I mean, to like put taxes on the bad guys instead of subsidizing the good guys, or I mean, is anyone talking about that, or is it only like subsidizing them?
I think connected to macroalgae, I did not hear any opinions about this because I think it could be easier to get subsidies for such a small industry than to get the big industry to be taxed for doing bad things. But it would definitely be another option.
Dinesh?
In a holistic view, what is like the major challenge that you faced to do this thesis in the aspect of collection of data and also analyzing these different aspects? I think a lot of effort went behind. You could share what is the major challenge of
the major challenge for me was that I neither had knowledge about macroalgae nor about the TIS analysis. So it was always a balance between learning more about one aspect and then having to catch up on the other. So that was quite challenging in 4 months.
No.
Now we talk about West Sweden.
Yeah.
And maybe there is a great potential for growing here, macroalgae. But if this is more of a problem solver when it comes to nutrients, then maybe the Baltic Sea is more interesting because they have tougher problem with that. Is there any experiments going on in the Baltic Sea, and is there a reason for that more nutrients, or what kind of things are happening there?
They have a huge research project in general on marine sciences to support cleaning the Baltic Sea. A problem that, for example, Western Sweden is not facing so much as the Baltic Sea connected to algae is that they have a lot of free-floating algae, and they have, as I understood, too much growth of algae. So they were tackling more ways to harvest the algae that is already there than, for example, in Western Sweden, where they're really interested in growing it. But I used it to benchmark a little bit, but since it was outside the scope of the TIS, I did not include the Baltic Sea, but it's definitely, they're doing way more research there.
Johannes?
In the other case, what about here at the West Coast, you add additional algae for growing. Do you also see like threats coming up because it might pose an imbalance to the ecosystem when adding the? If you also look into talk a lot about opportunities that we have to, you also look into threats that might be put.
They're currently researching that topic in a way that if you add algae cultivation sites, it changes the current of the ocean, as I understood. but I think the way I rather see it as that the ocean is highly unused. Someone is shaking his head there. But yeah, that's what I understood. That why are we not making use of the ocean that's just out there, but instead trying to spread more biomass production on the land that's already has exploited soil.
And what do you think about the mindset of consumers? Are people willing to start eating algae instead?
I mean, it's a movement right now, especially when it comes to like artisanal food. Algae is a really fancy thing, but I don't think that the market is so big, because to most people it does not taste as good. So this is the reason why you have to look at diversifying product range.
Comment to John, the limit is too low in the water for real production. And then I'll get
But it's also something positive also for instance, in the biorefinery to have low amounts of salt in the biomass. So.
Yeah, but I mean, you can't grow this kind of brown and grow well. Yeah, so marine biomass. But the productivity actually is very high. We have higher productivity on the Norwegian west coast than many places. I like cold water.
Thank you.
More questions? The city where I live, when I walk on the beach in Falkenberg, there are some old culturally preserved houses, and one of those houses is an old institutional remainder of when Sweden had on the beaches. There were people from the government were located there to prevent people from going and harvest the seaweed from the beaches. It was considered an incredibly valuable resource. They have specific days when you had the person from the government standing there and said, okay, you guys, you have this section, you guys, this farm has this section. Now you're allowed to walk down to the beach and harvest this. If you did that the day before, this person had quite the amount of force to prevent you to do that. So it's nothing new for us to utilize the biomass in that sort of simple way. And right now we are digging up holes in Morocco to extract phosphorus, and with it comes cadmium and all other nice metals, and then we spread it out on our fields. So is that a good first start maybe to sort of like close that agricultural loop better than a biorefinery?
Could you clarify your question?
Yeah, is it better that we take up what we have and use it for fertilizing as a start, rather than building biorefinery infrastructure and what that you proposed here?
I mean, it depends on which kind of products you want to produce in your biorefinery. If you just want to make fertilizer and biogas out of it, it's not going to be feasible. So you kind of have to, as Simon and Lovisa talked about, you have to bring the value of your product up. So then utilizing the nitrogen maybe as a food source, as proteins, would be better than just using it as fertilizer in a way. I'm not sure if I answered your question.
No, I was just questioning why you chose biorefinery, which is quite a complex starting point when you want to utilize marine biomass. I know there are, for instance, biogas fertilizers down in Helsingborg where they use seaweed, and they have a huge problem there with that type of weed on the beaches. So I was just wondering why you chose that area, since we have been working in Sweden a long time ago with using the seaweed as a fertilizer.
Yeah, I think, for example, the case you mentioned is that they want to get rid of their macroalgae. But if you have to cultivate it, it's more expensive. So then there's no way to make it feasible by just producing biogas. You have to produce products of higher value in order to make the project feasible. And this was done by researchers, and I think they have a more realistic mindset when it comes to the system that they have to operate under. They don't wait for the politicians to change the system to make it operable for them. They're looking at ways how I have this system, how can I make it feasible? I think.
But thank you so much for the really nice presentation, and another round of applause for Tina. Now for something you have never experienced before, a 2-hour lunch break. So we will be back here again at 2 o'clock, and for the final presentation in chapter.
Jag vill bara tacka för inbjudan.